So this is a brief theory video explaining how to animate a dinosaur walking. And the trick with animating a dinosaur is to understand that a walk is a controlled process of falling over and catching ourselves. It is not dissimilar to the way humans walk. At least the fundamentals are reasonably similar, because the dinosaur we're going to animate is a biped and humans are bipeds, and most of us walk in similar ways. This image here is taken from the Animator's Survival Kit, and this is a highly recommended resource for animating walks. So where do we begin? Apologies for the formatting error here. We begin by looking at the closest living relatives of dinosaurs, and that means looking at birds. Now, the largest living bird, I believe, is an ostrich or perhaps an emu. And if you look at the ostrich in this image, you'll see that it's not a million miles away, anatomically speaking, from the dinosaur. So we should always, before we start animating, do our research, go to YouTube, Getty Images, BBC, Animal Images, any place where we can get good reference to really dig into how these things move. What we shouldn't do is study what other animators have done, because then you're studying something that is already once removed from the source material, which in this case is birds. So what rig are we going to use? We're going to use this rig here. It's free. It's called Dino Rig version 2. It's by a very talented artist called Harry Gladwin Gyogigan. I don't know how to pronounce his name, and Harry, if you're listening, I apologize if I'm pronouncing it wrong. The rig is free for download at Creative Crash, and before you do anything else, I would go to Creative Crash, find the rig, and download it. So, if we take a look at a human biped walk, if we take a leisurely walk on a 16-frame cycle, which is the basic walk that we're going to be doing in this tutorial, we'll start with the right foot contact position here, into the squash, where both feet are taking the weight, then the passing at frame 9, then the up position at 13, contact again, this is the mirror image of frame 1 at frame 17, squash at 21, passing at 25, up at frame 29, and then back into the right foot contact position at frame 33, which is the same as frame 1. So that's the basic formula for what we're doing. Now, there are two ways of animating a walk. You can either animate the character walking on the spot on a kind of imaginary treadmill. That's why I've got this image of a treadmill here. Or we can literally advance the character across the screen and then use the world control to pull them back to the origin, a kind of counter animation, if you will. Now, both are completely legitimate ways of animating a walk. Both have their advantages and disadvantages. In this tutorial, we're going to use the treadmill option. So we're going to animate the character walking on the spot, which means that the character's feet are going to have to animate underneath him or her while the body remains in place. So we'll start with the right foot contact position, just like in the human walk. This is also called the stride position. And we'll set a keyframe at frame 1 on all the main controls, and also at frame 33, because remember, this is a looping cycle. So frame 1 and frame 33 have to be the same. The next thing we're going to do is the mirror image, and that's the contact position with the left foot. So the left foot is contacting the ground. This is the halfway point at frame 17, and now we will have two contact positions. The right foot contact at frame 1 and 33, and the left foot contact at frame 17. Once we've done that, we will add the right foot passing position at frame 9. And it's called the passing position because the weight is transferring or passing from the left leg to the right leg. Then once we've done that, we'll go ahead and add the left foot passing position. That's at frame 25. And here the weight is passing from the right foot over to the left foot. And this, again, it should be a mirror image of frame 9. It should be exactly the same, only in mirror image. Once we've done that, we've got all the main positions in place: 1, 9, 17, 25, and 33. So now we're going to start adding the breakdown positions. And we'll do that at frame 5. We'll add the right foot down position at frame 5. Now, this is where both feet are taking the weight. So on our imaginary treadmill, both of these feet are going to be traveling backwards because they're both taking the weight. Neither foot is in motion at this point. Gravity is acting on the body. Both feet are taking the weight. Then we put in the mirror image of that. It should be a mirror image. It's actually not in my thumbnails here, but which is a mistake. These feet should be in exactly the same position on the grid as they were in frame 5. So 21 and 5 should be mirror images of one another. Now we add the up position at frame 13. This is the uppermost position. This is the body at its highest point. And the passing foot, in this case the right foot, is now coming in forward for the contact position. We'll do the mirror image of that at frame 29. That's the left foot up position, the highest position on this side of the cycle. And now the left foot is coming forward for the contact position. And once we've done that, we've really got all our main positions. 1 for the contact, 5 for the right foot squash, left foot passing, 13 left foot up, and right foot contact, and so on. And you'll see that what we did was we did the position 1, position 33, which is the same as 1, then 17. Then we added 9 and 25. Those are the main breakdowns. And then the other breakdowns here, 5, 13, 21, and 29. So we're adding in all the elements. Then you turn on your infinity curves. I'll show you how to do that in the tutorial, and make sure that the cycle is looping nicely. Once you've done that, you've got to add flexibility because it will all be rather stiff. If you think of how a chicken or a bird walks, when the body goes forward, the head goes back. When the body goes back, the head goes forward. So we'll get a little bit of the same action going on the dinosaur. Again, as the body goes up, the head is going to tend to rotate down. As the body goes down, the head will tend to rotate up. Remember Isaac Newton, every action has an equal and opposite reaction. And obviously, we don't have to worry about Newtonian physics, but we do need to worry about cartoon physics, which is a kind of interpretation of Isaac Newton. The torso, again, the torso will tend to rotate against the motion of the body. The arms will do the same thing. As the body goes down, the arms will tend to go up, and the reverse is true. And the tail, this will be the trickiest bit, we're going to have to get a kind of wave action going, almost like the tail of a fish, which will counteract the main motion of the body. Once we've got our walk cycle working, we're going to want to add a setting. Ask ourselves, where does the action take place? Is it going to be in a human environment like a city, or a natural environment like a desert? You don't want to spend a whole lot of time modeling sets and props, so I recommend going to a website like TurboSquid or the free 3dmodels.com and see what they've got. There's some really nice sets there. One of the advantages of being in a human environment like a shopping mall or a building is that you can close off your set, and when you come to light it, you don't have to light infinity, because you can create a closed set. But it's really up to you and what kind of a setting you want to create. So that's it. The next stop is to download the rig and show you the controls, and then we'll start animating.